Hello viewers on YouTube. In this video tutorial, we are going to prove the derivative of cosecant x. So what says the derivative of cosecant x? It says that if y is equal to f of x and f of x is equal to cosecant x, then the result for the derivative, the y dx, that is equal to negative cosecant x cot x, where cot is a cotangent. It is often pronounced as cot for short. And the goal and the purpose of this video is to figure out how this formula is formed or how this derivative is formed. And we are going to be considering using the definition of derivative for that. So what says the definition of derivative? It says that if y is equal to a function of x, then the derivative dy dx will be equals to the limit as h approaches 0, where h serves as the delta x, of f of x plus h minus f of x, all divided by h. Perfect. Now, f of x, earlier we said is cosecant x. However, cosecant is a reciprocal function. So we need to understand the function. It turns out to be its reciprocal. Cosecant x, CSCX, is simply the reciprocal of sine function x. How we can see that is 1 over sine of x. And we can set that properly. Perfect. So if that is the case, then that means f of x is equal to 1 over sine of x. Now, if f of x is 1 over sine of x, what would be f of x plus h? Well, what f of x plus h means next sense is that wherever we see x in 1 over sine x, we should replace with x plus h. So therefore, here we have 1 over sine of x plus h. Perfect. Now we have f of x, likewise f of x plus h. We can proceed on this. So therefore, the derivative dy dx will be equals to 1 over sine x plus h minus f of x, which is 1 over sine x. Then entirely we have division of h, which is here, okay, from the formula, division of h. Perfect. So don't forget the limit is still there. So the goal now is to simplify this entirely. But before we proceed on making any substitution, let's simplify the fraction. So I'm just going to first of all change this number line division into a regular division. So therefore, I now have the y dx. The y dx, there is a separator, is now equal to the limit as h approaches 0 of, so I'm keeping this one, 1 over sine x plus h, the minus 1 over sine x. Now this number line division, instead of this long division, let's use the regular one divided by h. Now we can use the method of keep, change, and flip. We keep this entire expression, change this one to product, then flip this one. Just as if we are having h over 1. When we flip it, it becomes 1 over h. So therefore, the y dx becomes the limit as h approaches 0 of 1 over sine x plus h minus 1 over sine x, then times 1 over h. Okay. Now, before we multiply, let me combine this expression. Okay, I'm trying to find the LCM and then simplify it. Perfect. I hope you are following. So therefore, we now have the y dx to be equal to the limit as h approaches 0. So the LCM will be their product because they are expressions, not a constant value. So we have sine x plus h times sine x. Then we have divided by. So sine of x plus h in this entire expression gives us sine x, and multiplying with its numerator gives us sine x back because the numerator is just 1. Then we have the sine connecting them, which is minus Sine of x in this entire expression gives us sine x plus h. Multiplying by its numerators gives us sine x plus h back. So we have minus sine x plus h. Then we see have times 1 over h. Now at this point, this h can multiply this. So we have it to be equals to the limit as h approaches 0 of sine x minus sine x plus h, then entirely divided by sine x plus h, then times sine x, then again times h. Perfect. Now at this point, what I would like to do is that we need to make use of some substitution. We want to expand this sine x plus h. And to expand that, we use some of our trigonometric identity. And this is the one we'll be considering using. Compound angle formula. The sine of the sum of two different angles is sine of the first, cosine of second, plus cosine of first, sine of second. So that's the expansion we'll be considering using this time around. So therefore, simplifying forward, we have dy dx equals to the limit as h approaches 0 of sine x, the minus. So sine x plus h, we said that will be, since this minus we need to take effect, let's just put this in a bracket. Then we have sine x cosine h, then plus cosine x sine of h, sine h. Okay. Then we have the division of sine x plus h times sine x times h. Okay. So right now, let's distribute the minus. This is equal to the limit as h approaches 0 of the following of sine x, the minus sine x plus h, or sine x cos h rather. Then again minus, when this minus multiply this one, we have again minus cosine x sine h. Perfect. Then divided by sine x plus h times sine x times h. I hope you are following, makes sense. So that is where we have for now. Now I'm out of space, so we need to move forward. Okay, so I need to write it down first before we get rid of it entirely. So let me just shift this a little bit downward. Okay, so therefore dy dx is now equal to the limit as h approaches 0 of sine x minus sine x cos h, again minus cosine x sine of h, then entirely is divided by sine of x plus h, okay, then sine of x times h. Okay, so these can be taken away, and then we'll continue with this slide. Oops. Perfect. So now therefore, at this point, let's try and factorize, or let's just take this sine x outside first, because it's a common factor. Not common, actually, it's a constant, because the limit is such that it's approaching, h is approaching, it's with respect to h, but this is sine x, so we can take it out of the limit. So we have dy dx is equals to 1 over sine x times the limit as h approaches 0 of sine x minus sine x cos h, the minus cosine x sine h, then entirely is divided by sine x plus h, and again sine, okay, normal sine, but just h. Sine has gone. Okay, now let's try and detach this sine x plus h as well. So therefore we have 1 over sine x, however it will still be within the limit because it has h down, times the limit as h approaches 0. So I'm putting within the parentheses 1 over sine x plus h times, so this as well, that will be sine x minus sine x cosine h, the minus cosine x sine h, then entirely is divided by h. Okay, so now we have 1 over sine x the limits can be distributed because this is limit of product and the same thing as product of limit times the limit as h approaches 0 of 1 over sine of x plus h times the limit as h approaches 0 of, so let me distribute this h as well for each of this term, not each and every one, but these two terms, this as 1, this as 1. So we have sine x minus sine x cos h divided by h, okay, then minus the limits will take effect. Let me just distribute direct, okay. If I should put it in a bracket, then we need to repeat the process again, but I'm trying to distribute the limit direct, so that will be the limit as h approaches 0 of cosine x sine h divided by h. Good. So sine s can be taken as a common factor here, and in fact it can go outside the limit because it's not with respect to h and does not have any h term. Same thing applies to cosine x, it comes outside the limit. So we have 1 over sine x times the limit as h approaches 0 of 1 over sine x plus h times sine x multiplied by the limit as h approaches 0 of 1 minus cosine h, all divided by h, the minus cosine x multiplied by the limit as h approaches 0 of sine h over h. Good. Now at this point we can proceed on making our substitution. But before we do that, let's review some things. You need to understand that the limit as h approaches 0 of sine h over h, that gives us 1. Also the limit as h approaches 0 of 1 minus cosine h over h is the same as the limit as h approaches 0 of cosine h minus 1 over h, and at the end of the day the result will be 0. You can confirm that with your calculator. Make sure your angle is the angle is in radian. Then just plug in the value that is approaching 0 into this expression. You should end up with the corresponding results. So let's proceed forward. Therefore, the y dx is now equal to 1 over sine x times the limit as h approaches. When we put 0 here, we just have 1 over sine x, 1 over sine x times sine x. Now we said this entire expression becomes 0 times 0, the minus cosine x. This entire expression becomes 1 times 1. So this term becomes 0 entirely. We have the y dx equals to 1 over sine x times 1 over sine x times, this is the product. This is the product because they are still multiplying themselves. Alright? They are still multiplying. This one is multiplying everything entirely. Then put it in the bracket. Okay. And there's times here. It's not just this one alone, it's multiplying. It's multiplying this one as well. So it's just as if I'm having times negative cosine x. So therefore, simplifying forward, we have 1 over sine x times negative cosine x over sine x. Now 1 over sine x earlier we said is a reciprocal function and it is cosecant x. So final answer in this case will be cosecant x, CSC x. Then cos x over sine x is negative tan x. So the minus cos x to say not tan x. And that is how the derivative is formed. So that is why the derivative of y with respect to x, if y is cosecant x, is equal to negative cosecant x cot x. And I hope you find this helpful and understandable. Thanks for watching. If you haven't checked out my video on derivative of trigonometric function, you can always check it out in the playlist. And I'm going to leave the link in the description of this video. Thank you once again. See you in the next video. Bye for now.